Hey there, creative coders! This is Benjamin D. Whiting, and welcome back to the Super Collider segment of Null-state's interactive digital art tutorial series. Last week we discussed the use of arguments to allow for the creation of modular, externally manipulatable sound-generating functions. This week we will touch upon the use of arrays as a way to collect and store sets of data, and another look into the use of arrays to engage in multi-channel expansion. Let's get started. An array is a data structure into which data is collected and stored. Each entry is identifiable and accessible by an index number. Arrays in Super Collider are zero-indexed, meaning that the first index number is 0, not 1, as is found in languages like MATLAB. As witnessed in our brief excursion into multi-channel expansion in last week's episode, commas separate the indices, and the entire array is enclosed within rectangular brackets. The following is an example of an array of integers. Here, the 5 is placed into index 0, the 7 into index 1, and the 3 into index 2. Arrays can house a wide variety of objects, from integers, floats, and variables, to functions and even other arrays. It might be useful to conceptualize an array as a chest of drawers, where each drawer contains some object, but the chest of drawers itself is no less of an object and can be referenced as such. Just as chests of drawers need to be built before anything can be put within them, arrays need to be initialized before they can be used to store objects. Like much of what we've discussed thus far in Super Collider, this can be achieved in a myriad of different ways. The basic way of initializing an array is by using the .newClass method, declaring its maximum index number and setting it to a variable. This sets up an empty array, as you can see in the post window, and the array is large enough to fit up to 3 indices. Remember, arrays are zero-indexed, so index number 2 is actually the third slot. Let's now set up the array we had earlier. This is most easily accomplished by using the .addInstance method of array, the sole argument of which is whatever you wish to place in the next available slot. As you can see in the post window, our array now contains one object, the integer 5. We can confirm this by invoking the .addInstance method and checking the first index, being index 0. Now, let's follow suit with the next 2 indices. We could continue adding the numbers one at a time via .add, or we can add both numbers at once using addAll. And just to check and see that these integers were successfully added, now let's say we suddenly realized we miscounted and wanted 4 indices in this array after all. Could we simply add it to the array and hope for the best? It worked! Let's keep going though, something doesn't quite feel right. Aha! Instead of appending the integer 8 to the array, it simply overwrote the 1. Or did it? Let's check to see what is actually registered in the 5th slot, or index 4. And there we have it, nil. Despite what we saw in the post window, there is technically nothing in index 4 of our array. What's actually going on here? While Super Collider could have simply thrown an error, halting whatever process is being executed at the moment, it instead generated a new array with the requested data added to it. This design choice was likely due to the language often being used in real-time musical performances. There's no reason to bring everything crashing to a halt for accidentally underestimating the size of an array upon declaration. The fact that some leeway is built in for eclipsing the declared maximum size supports this notion. That said, Super Collider has no built-in way to retain this new array, so when adding anything to an array, it is far safer to always store it in a variable. In fact, one might as well consider it a mandatory part of the process. Now that we know how to add data to an array, how might we go about updating an array's indices with new data? While there are many options to go about doing this, the method we'll focus on today is the .putInstance method. Let's say we want to replace the 5 in index 0 with an 8. We could achieve this by invoking the following. Unlike .add, .put does not have the capability to return a new array should the desired slot not be available, so there is no need to set the result back to the variable, though it doesn't actually hurt anything if you did. Not properly accounting for this limitation could lead to some process halting and throwing an error, however. For instance, let's say we try putting a 1 into index 5, which does not yet exist. We get a lovely index out of range error and nothing else gets accomplished. Likewise, let's try putting something into index 0, our very first index, upon initializing a new array. We get the exact same error. Despite being initialized, the array does not yet have any indices to place data into. Going back to our chest of drawers analogy, one can think of .add as both building the drawer for a new slot as well as placing the desired object within. Until the drawer is built, nothing can be placed into it, despite the array being large enough to accommodate it. This is where the newClear class method of array comes in handy. If one is wanting to initialize an array and immediately start putting data into its various slots, especially if one is looking to do so non-consecutively, where .add would not be helpful, one has the option of instancing an array pre-filled with objects using .newClear. Said objects are actually nil, which represents uninitialized data, but nil is technically an object in the eyes of SuperCollider and thus results in all indices being available to put data in from the start. In other words, we're building the chest of drawers along with all of its drawers in one fell swoop. Note that the argument in newClear represents the number of indices pre-filled with nil, not the maximum available index number. Therefore, indices from 0 through 4 are available. As you can see in the post window, we were successfully able to place our 9 smack dab into the middle of our array, surrounded by indices that have yet to contain initialized data. Incidentally, we have some syntactical alternatives to a couple of the instructions we've dealt with today. For example, instead of explicitly invoking the .put instance method like we just did, we could instead set a value directly to an index of our array. The syntax to achieve this would be one that might be more familiar to programmers of other text-based programming languages, that being the variable housing the array followed by the index identifier in brackets. Using this approach, this is how we'd set the value in index 4 to 20. As always, personal preference prevails. While I have utilized both syntactical forms in my code, I do tend to favor setting to an index using an equals sign, as seen in our latter example, than putting into an index. Likewise, when checking the contents of an index, we can dispense with .at and simply use the above syntax without setting it to anything. Furthermore, when initializing an array, we could have completely dispensed with the .newClass method. For most SuperCollider classes, the .newClass method, if available, is understood and thus optional to type. Here we've set up an array with a max index of 10. I go back and forth depending on what class I'm using as to whether I omit the .new, and you'll likely see me type it just as often as not. Nevertheless, it is something to keep in mind. Returning to the array class and looking up its documentation, one can find a wealth of class and instance methods that will allow one to initialize and transform their arrays in almost any way one can think of. I highly recommend spending some time playing with each of these to get a feel for what they can do. As you can see, one can even initialize an array pre-filled with a Fibonacci sequence, rendered as floats. If one wishes to initialize an array and already knows precisely what one wants to fill it with, one can dispense with the initialization process and simply declare its end result. Or, if one wants to set up an empty array, this does not allow one to specify a max index size, thus retaining its default 0. But if one is diligent in always setting the result of a .add action to a variable, there is very little downside to this approach. Still, gaining familiarity with the various class methods that aid in the filling of an array with data will prove immensely helpful, especially when setting up large arrays and those that are filled by the results of functions. Finally, since I feel bad that we haven't done anything with sound at all this episode, let's revisit the use of arrays to invoke multi-channel expansion. Since we're going to be audiating our results, let's finally boot our server. Yes, we've been able to accomplish everything this episode so far without utilizing the server at all. We'll discuss why that is next episode. If you recall from last week, we set up a function that contained two sign-asks, one in the left channel that would pulse every 2 seconds, and one in the right that would do the same but was offset by 1 second. This was achieved by declaring an array and putting the two sign-ask ugens in indices 0 and 1. With 0 outputting to the left channel and 1 outputting to the right. This proved to be advantageous as we wanted to control both sign-asks independently, but what if we wanted to simply output a sustained chord instead? Do we really need to type out the full class plus audio rate method with all arguments filled for each individual note of the chord? Good news! No, we do not. To illustrate, let's construct a function that will take a note and output a major third based on that note, with a fade time of 3 seconds. I'm choosing to use the MIDI to cycles per second conversion as I find it far more intuitive for this purpose. Now we could form it like this. However, we're just about to see a significant limitation of function.play. Let's now output a major third based on E. We could reevaluate our code by replacing the default in the argument declaration, but that's hardly a modular approach. Instead, let's try simply appending .play to our variable, thus passing the MIDI note value into the note argument. Wait, what is this? Why are we getting an error, and what's this synth temp __ 0 being referenced here in the post window? The thing is, the .play instance method of function is what's known as a convenience function, in that it performs a chain of several commonly used operations that are meant to make life easier for a programmer. Let's take a look at its documentation to see what is going on behind the scenes. As stated here, it plays a synth, notice the capital S here, from ugens returned by the function. It wraps the ugens in something called a SynthDef and sends it to the target, in our case, the default server since we never specify one. What's actually happening then is that ~chord is not being set to the function, but instead to something called a synth that's being generated from the .play instance method. Furthering this suspicion is that, if you notice, .release isn't an instance method of function at all. It's a method of node and, upon looking here, it's not even inherited by function, but it is by synth. This means then that we'll need to unpack this convenience function a bit to get the results we want. We will do this more completely in a future episode, but for now we'll make use of another convenience function enabling us to take a bit more control, that being .asSynthDef. .asSynthDef takes us as far into the process as wrapping our function into a SynthDef, but stops short of actually invoking the synth. There is a similar method called asDefName which automates just a little bit more of the process, but oddly does not allow for the use of fade time. asSynthDef also provides a bit of a better bridge to programming our own SynthDefs later on. First, we do not set this function to a variable. I mean, we could, but as we won't be referencing this function again, it would serve no real purpose. In addition to supplying our fade time, we give a symbolic name to our new SynthDef. As discussed last episode, a symbol in SuperCollider is text either enclosed in single quotes or prepended with a backslash. It is this name that we will be referencing. Finally, we add one more method to the end here, one that wouldn't have been necessary with asDefName, which is .add. This is an instance method of SynthDef and is necessary to be able to address this definition in subsequent instructions. Next, let's instance our synth. We do this by setting the synth to a variable. .play is not needed here. Now, let's hear that lovely major third based on E. We can pass our arguments into the SynthDef in a manner similar to what we witnessed with .play. Great! Now let's adjust our code to produce a proper major triad, and let's hear a G major triad this time, with a slightly narrower width of the saw wave. Wait a minute, why do we only hear the root and the third? Where's the fifth? If you think about it, haven't you noticed that the root is always coming out of the left channel and the third out of the right? That's because, even though we're only using an array for the frequency value, we're still invoking 3 unique UGens to handle the task. We could have written out 3 individual varsaw classes, one for each frequency, and wrapped everything in an array. That would have been a colossal waste of keystrokes and space for our purposes, so SuperCollider allows for the use of arrays for individual arguments within classes, and will expand accordingly behind the scenes. So, unless you're monitoring this exercise over a multi-channel setup, in which case the fifth will be sounding out of output channel 2, it remains inaudible as SuperCollider will not automatically wrap the sound back around to output channel 0. Remember, 0 indexed. What we want now is to mix the 3 signals together, and for that we'll use the mix class. We now have all 3 members of the chord sounding, but we're back to hearing everything emanating from the left channel. This is because mix will combine all signals, that are themselves not arrays, into one audio or control bus. Can you guess how we can restore sound in the right channel? I'll give you 5 seconds. By the way, we've been using the .new class method of mix, so its specification is not mandatory. There are .ar and .kr methods as well, but they're now obsolete as .new can switch between audio control rates automatically. Still, they've been left in the language for backward compatibility reasons, as specifying the distinction was required in SuperCollider 2. Using them can sometimes be a helpful reminder as to what kind of data one is handling in a given instruction, especially if one is wrapping variables within mix that were initialized elsewhere. This wraps up our episode on arrays, as well as revisiting multi-channel expansion. I know I had promised to include iteration in this episode, but upon further introspection I feel it's better suited for an episode after discussing the difference between client and server-side programming. When will we be discussing this, might you ask? Why, next week, of course. In the meantime, please don't forget to hit that like button and subscribe to this channel to show your support for more interactive digital music and art content from us at Null-state. Also, make sure to check out our Facebook page and webpage to stay up to date on all of our upcoming events, workshops, and concerts. The link is in the description below. See you next time!